Let's look at the solution of modern maths bites. The manufacturing company conducted workshops on 3 different techniques, namely designing, formatting, and testing for its executives. The number of executives who attended the workshop on designing is twice and thrice the number of executives who attended the workshop on formatting and testing respectively. Okay. So let me draw a Venn diagram. Designing, formatting, and testing. In the line given was number of executives who attended the workshop on designing is twice and thrice. So it should be 6 times of something. Those who attended the workshop on formatting, so this should be 3x and this should be 2x. Okay. 42 executives attended the workshop on formatting. Formatting is 42, which would mean testing is 28 and designing is 84. Okay. The aggregate number of executives who attended the workshop on exactly 2 techniques is at most 25% of the aggregate number of executives who attended the workshop on exactly 1 technique. Okay. So these 3 ticks and these 3 crosses. We know the crosses have to be less than equal to 1/4 of ticks. Okay. Workshops on any combination of exactly 2 techniques was attended by more than 1 executive. Okay, so each of these crosses have to be at least 2. Have to be at least 2. By more than 1 executive would mean each of these crosses are at least 2. If the maximum possible executives attended the workshop on all 3 techniques, we have to maximize this now. Then find the maximum possible number of executives who attended the workshop on both designing and formatting, but not testing. We have to maximize this region. And we know this is maximized. Okay. Based on the conditions I know these crosses have to be at least 2. And then this overlap of all 3 regions has to be maximized. Out of these 3 sets, testing is the smallest set. So in order to maximize the overlap of all 3, the best case possible would be if this is 2, and this is 24, all 28 people recorded here, this is 0. Now I'm taking this middle portion as A. Only one within formatting would be equal to 26 gone. So 16 minus A. And only one within designing will be 26 gone. So 58 minus A. Now we simply have to ensure this condition. Crosses is equal to A plus 4. This has to be less than equal to 1/4 of 58 plus 16, 74. 26 gone, yes. 74 minus 2A. This is done. So I get 4A plus 16 is less than equal to 74 minus 2A, or 6A is less than equal to 58, or A is less than equal to 9.66. Given that A is count of people, it can only be a whole number. So the greatest possible value that A can take has to be equal to 9. Therefore, the answer to the first question is option C. Next question. There are 6 gentlemen and 4 ladies to dine at a round table. In how many ways can they seat so that no 2 ladies are together? Okay. Given that ladies have to be separated, first I have to ensure that gentlemen act as partitions. 6 spots, 6 gentlemen, they can be rearranged in 5 factorial ways. Now, among the 6 spots generated, these spots that are marked by an arrow, females can occupy any 4 spots. So let's select those 4 spots in 6C4 ways, and then females can rearrange themselves in those 4 spots in 4 factorial ways. Altogether, this is what we should be getting. Okay. So I have 5 factorial into 6 factorial by 2 factorial, 4 factorial into 4 factorial. This and this will get cancelled. I'm left with 5 factorial into 6 factorial by half. Among the available options, the one that works is option C. Next question, and this is an amazingly wonderful question. There are n necklaces in a safe box where n is greater than 1. Okay. N we have and n is greater than 1. Every necklace has the same number of diamonds. Each necklace has at least 2 diamonds. So let's say diamond per necklace is D and D is greater than equal to 2. Conditions and conditions is given. If the total number of diamonds in these n necklaces is between 500 and 600. So we have been told ND lies in the range 500 to 600. If this data is sufficient to find the value of n, what is the value of n? Okay. If this data is sufficient to find the value of n, what is the value of n? So things that should run in your head. Basically, we have to come up with a number. We have to come up with a number that can be broken down into exactly 2 factors. If it can be broken down into more than 2 factors, then this will be a problem. This will not work. This will not work. So I have to find numbers within 500 to 600 range, which can be broken down into 2 factors. So the initial thought, of course, will be a prime number. Initial thought will, of course, be a prime number. Let's see if we can identify a prime number. 503, would it work? Is 503 a prime number? 501 is not a prime number. 502 is not a prime number. 503. So under root of 503 will be 22 point something. 22 also 19. So 380 plus 123, not divisible by 19. 17. 510 minus 7, not divisible by 17. 13 is 520 minus 17, not divisible by 13, not divisible by 11, not divisible by 7, not divisible by 5, not divisible by 3, not divisible by 2. Okay. So 503, idea wise, 503 comes. But as soon as you reach 503, can you see, even if you were to break it down into 2 numbers, the 2 numbers would be 1 into 503. You would not be able to fulfill both these conditions. If it was a prime number, it will break down into 1 into a prime number. And as soon as one of the constituents is n, either n is violated or d is violated. So prime number as an idea doesn't work. Then we have to think of something else. And the hint here is, if this data is sufficient to find the value of n, can you see, it wouldn't matter whether you identify n or you identify d. Even if they flip over, even if they switch values with each other, you'll get to the same result, which is another way of saying that we are looking for a perfect square in this range. So in the range 500 to 600, I either have 529, which is 23 square, or I have 576, which is 24 square. One of these 2 has to be the answer. Now, if it is 23 square, because I have to fulfill these conditions, n has to be greater than 1 and d has to be greater than equal to 2, the only possible case is 23 into 23. But if I have 24 square, I could have 24 into 24, or I could have 12 into 48, or I could have 6 into 96. I can have multiple cases if this was the case. If 576 was the total number of diamonds present, then I can have multiple cases, multiple values of n, and then the data would not be deemed sufficient, which would mean the only possible value that n can take, that will guarantee that you identify the value of n is 529, and the value of n in that case would be option B, 23. Please, if you haven't understood it, rewatch the video, go through every argumentation. This is not a maths question, this is a theory question based on beautiful understanding of language. Okay, next question. 9 dots are placed on a piece of paper. Find the maximum number of right angled triangles which can be formed by joining any 3 dots. Okay, I'm making 9 lines. I've got these 9 points. Now, how many rectangles can be made? I'm asking how many rectangles can be made? Because as soon as you identify a rectangle, can you see if you have a rectangle A, B, C, D, you can break it down into 1 and 2, two right angle triangles, and A, B, C, D, also 3 and 4. Every rectangle can be broken down into 4 right angled triangles. So how many rectangles can you make? 3C2, 3 lines, select any 2, and 3 horizontal lines, select any 2. You can make 9 rectangles, and every rectangle gives you 4 right angle triangles. So we already have 9 into 4. I'm naming these points also: A, B, C, D, E, F, and G, H, I. We have 36 rectangles identified. We have at least 36 rectangles identified. This is not the end of the work. This is not the end of the work. See, the next level of working would be, can you see, this will also be a rectangle that gets created. You will also have a rectangle D, B, F. And if you are able to make D, B, F, can you also make D, H, F? Can you also make D, H, F? Basically DF as the central point, and then triangle on the top, triangle at the bottom. Similarly, can we make ACE and GHE? Triangles like these are getting created. Like these are getting created. Do we know these are right triangles? Do we know these are right triangles? Very much so. Look at this. If GH is 1 unit, this is 1 unit. So DH will effectively be equal to root 2. 1, 1, root 2 is a right angle triangle. Yes. So if this is root 2, DH is root 2, and HF is root 2, and DF is 2. Root 2, root 2, 2. That is also a right angle triangle. We get 4 more. So we initially had 36. We've got 4 more. But this is not the end of the work. First, let me erase these triangles. Okay. The other 4 triangles that can get created, what color do I use? Red I've used, blue I've used. So let me use purple. Look at these triangles now. These would also be triangles that are useful. So A, E, G, and B, F, H, and C, E, I, and B, D, H. There will be 4 more triangles like this. So I have 36 from our original individual rectangles. Then I have 4 more which are not from rectangles, 4 more which are not from rectangles. Altogether, how many right angle triangles can be formed? It would be 44. Last question. A mathematics problem is given to 2 students, W and Bablu. The probability that of W solving it is 3 by 5, and the probability of Bablu not solving it is 4 by 5. Okay. So W solving is 3 by 5. W not solving will be 2 by 5. Bablu not solving is 4 by 5. So Bablu solving will be 1 by 5, because these are mutually exclusive events, mutually exclusive and collectively exhaustive. What is the difference in respective probabilities for both solving the problem? Both solving the problem would be given by 3 into 1 by 5 into 5. So 3 by 25. We need the difference between this and W not solving it and Bablu solving it. Okay. W not solving it is 2 by 5 into Bablu solving it is 1 by 5. So this is 2 by 25. 3 by 25 minus 2 by 25. We get 1 by 25. Answer should be option B. And that is the end of this sheet.